additional of external device, to the control system. So what we mean by the compensations is that we are adding, or we are doing additional. We are introducing an external device to the control system. So it is the additional of the external device, the control systems. So what are the importance of doing compensations? Why do we do compensations? So why we are doing compensations is because we want to have a system which is very stable at all time, a system which is very accurate, a system which is very stable, and it cannot fail. So to ensure that, we need to consider redesigning the circuit. So also compensation can be defined as redesigning the circuit. So what are the importance of doing compensation is, one, it leads us to what we are calling it requirement of compensations. Requirements of compensation. So we've got the three requirements which are very main, or the main ones. We have one called stability. Two, another requirement, we want a system which is accurate. So we also talk about the accuracy. Three, we need also a system that has a high speed response. So we've got these three requirements of compensation. So why we are introducing compensation is because it's one, to improve the stability of the system. Another one is to improve the accuracy of the system. And lastly, to improve the speed, or high speed response of the system. So these are the requirements. So as we have said, compensations is redesigning the circuit, or additional of external device to the control systems. Why we are doing that is because we want to ensure that the system is operating under stable conditions, and so it can also operate, or its operations can give the accuracy, and it got high speed of how to achieve compensations. How to achieve compensations. One way of achieving the compensation is by reducing the state error. So how we can achieve compensations is by reducing the steady state error. Now, how do we do this? This one is by increasing the forward path gain in the system. There is also a disadvantage of doing this. When you increase the forward path of that system, it will lead the system to be unstable. So one way of reducing this steady state error is by increasing the forward path. When you do this, then it leads to negative. So this one has negative effect of this method. One, leads the system to be unstable. So it leads the system to be unstable. Two, it makes the system to be oscillatory. It makes the system to be oscillatory. So these are the negative effects of doing or going by that method. It it will lead to system to be unstable. It will make the system to be oscillatory. So, and this oscillatory is brought in by the system itself is not stable. It is oscillatory. So that is one method of doing the compensations. We can achieve compensation by doing this. But now, looking at this method, it leads to some negative effects, and it will render the system to be unstable. So when you increase the forward bar gained in the system, it will lead the system to becoming unstable, and also the system become oscillatory. Another method. Now, number 2 is addition of balls and zeros. So this is another method of achieving the compensation. So let's start with zeros. When we introduce zeros to the system, it will increase. When we introduce the zeros, it will lead the system to be, will be stable. That is the positive effect of using that. So when you introduce zeros, the system becomes stable. The other one, the system speed, increase. The system increase. This is also another good one. The negative effect is that the accuracy is slow. So there's this one. It's slow. The accuracy, or accuracy decreases, or you can say accuracy decreases. So when you introduce zeros, the system will be stable. The system will be, the speed will also increase. But the one disadvantage of using this system is that the system becomes less accurate, or the accuracy of that one decreases. So that is one negative. But these others, this is what we want. We want a system which is stable and a system which is accurate. The balls. Now, when you introduce the ball to the system, it has negatives. The system becomes less stable. That is the disadvantage of introducing the ball. Another one is that the speed, the system operations slows down. So that is also a negative effect. We don't want a system which is operating that slows down, or a system that has less stability. We don't want such. But this one, it has a good thing, that the accuracy of the system increases. So that is a very important item from the balls. When you introduce the ball to the system, we have this, the accuracy of the system increase. So for us now to achieve, then you need to combine the balls and zeros. So from the balls, we pick the positive, and one of the positive thing about the ball is that the system accuracy increases. And then about the zeros, one advantage is that the systems becomes stable. Another thing about the zero poles, the zero is that the system has a high speed response. So for us to get that perfect system, then we need to combine the poles and the zeros, and those are the two ways of achieving the compensations. So as we said, one was we reduce the steady state error by increasing the forward path, and another method is by addition of balls and zeros. So when we add balls and zeros, we are going to get a perfect system, a system that operates accuracy, a system that has got high stability, and a system that has a high speed of response. So that is all about that. Then another subtopic of connections of compensations. So mode of connections, or the arrangements. How do we arrange the compensations? So we've got three methods. One is compensation series, or we say cascade compensation. This one, you can have the summing point here, and from the control system, the one we know. So then we can, if it is series, we can have this. We have this block to represent the process, and then we have the output. So here is the input, and so this one is going to be our GS, which is this one is the compensator, and this one is the process. So that is one way of arranging the compensators. So in series with the process. So that is one way of doing that. This is the compensator, this is the process, or this is the fixed point. You can call this one the fixed point. If you consider a loop, a unit feedback. That is one way of doing that. So we have series or cascade compensation. Number two is feedback compensations. That is another mode of connection. Listen, how do you do this one? We have here the input, we have here the process, input. Here is also another one. This is the process. This is the output. This is the compensator. This is the process. So this is also another one. This is the compensator. We call this one feedback compensation. And then lastly is the load compensation. This one, how you do this one is this way. This is the input. This is the output. So we are combining the series and the feedback. So we're going to put here another one. So this is the compensator. This is the process. This is also another compensator. So, and that is how to do the load. So the load compensations is the combinations of the series and the feedback, and after that we make